Hi folks, Will from MinIO, and in this video, we're going to be showing you how to perform transforms with Object Lambda. We're going to start off with why you might want to transform objects. We're also going to show you how to set up that webhook. In the next video, we'll be talking about how to configure your client to request that object, and then how to configure MinIO so it knows where the webhook is. Let's go ahead and dive right in. So the first topic we're going to talk about is why might you want to transform objects? So the need for transforms is really that MinIO is going to store your objects as a binary large object. It's a collection of binary data. Different versions of an object are going to require the complete object. This is the way MinIO versioning works. And if you're going to be storing multiple versions of an object with some minor differences, that can cause redundancy, and then you have to keep track of which version you're going to download for which use case and all that other fun stuff. What the object transforms does for us is it allows us to let MinIO serve these minor differences without having to store multiple object versions. And this gives us a lot of flexibility. One example that we might have is if we were working with PDF forms. So what you might store in MinIO would be a simple blank sort of template PDF. And then if a known user requests that form, MinIO can then call a webhook that can autofill some of the form with that user information. We don't have to store all those different versions. We don't have to store a different version for each user. We can autofill it as we go. The data can be passed in by the user through a form, or the data can even be read from a database. You can do whatever you want because you're writing a webhook in whatever language you feel like, and we'll show you more about that in just a little bit. If nothing is passed in, of course, we can just send down the original blank form and they can fill it in themselves later. So this gives us all of the flexibility that we might want when serving up a PDF form. Some other examples, maybe you're serving up video and you want to re-encode to a lower bit rate or something like that. You don't need to store all the different bit rates on MinIO. You just store the highest bit rate and then you re-encode down before you send the object out. Lots of different ways that you can play with this. So how is MinIO handling all this? Well, the short answer is it doesn't. That's not what MinIO is for. MinIO is going to store the object. MinIO can call a webhook to make the changes on behalf of MinIO, and then MinIO itself still returns the transformed object. So the client is not really going to know that you've requested this transformed object if you've coded up your client well enough. But the main thing here is that as far as the client is concerned, everything is going through MinIO. So here's a diagram of how all of this is going to work. So if when our client makes a request to our MinIO cluster, MinIO is going to see that there's a Lambda request in there. We're going to send that off to our transform cluster, the Lambda webhook. The transform cluster is going to request the original object from MinIO, which then sends that original object over to our transform. We're going to make whatever transform changes we need to make and send that output back to MinIO, and then MinIO returns it to the client. So this is a lot of work going on behind the scenes so that our client just has to talk to MinIO. Very handy. So let's go ahead and talk about how to deploy a webhook. How do we make it so that MinIO can actually talk to this webhook? Well, all of this is basically what to expect when you're transforming. MinIO is going to forward the request to a registered webhook via post. It's always going to be a post. It's always going to be a known sort of event model that gets sent over. Since this is a simple HTTP request, any application that can accept HTTP can be used. We're not going to limit you there. You can write your application in any language that you want. And even better, the application itself doesn't have to know how to talk to MinIO directly. We'll get to more of that in just a second. The post contains all of the data needed to process your request, and it's all JSON formatted. You get, among other things, a pre-signed URL to get the original object, which means that I don't have to have my MinIO webhook. It doesn't have to know anything about credentials. It's going to get a pre-signed URL to get the original object. It's great. It also has output details to hand the transform back to MinIO so that MinIO can then hand it along to the client. And then we also get the original request URL, the original URL encoded request sent to MinIO. And the reason why that's important is that it allows us to have extra data sent in via the URL. So getting that original object. Rather than sending the whole object in the request, MinIO expects the webhook to pull the object. So this is very important. This allows our webhook to gather any other data needed as well as the object. And it also means that I don't have to grab the object first thing. I don't have to handle an object being handed to me. I can go off and say, oh, I got a request. I need to pull some data from the database. I need to transform this image. I need to call my AI calls or whatever it is I need to do in order to prepare to transform this object. And then when I'm ready to transform the object, I can pull that object in using this pre-signed URL. You'll notice that the pre-signed URL has, among other things, this XAMZ expires. So I don't have to call it instantly. I've got a couple of minutes that I can do this, okay? Now, the post puts this URL in get object context input S3 URL. And we'll see when we look at some code in just a little bit how this is all going to work. But that is where this is stored in the JSON. So as long as you can pull this out of the JSON, you can get the original object. Very cool stuff. As with all webhooks, you're going to have to give back a response of some kind. Obviously, we need to have the transformed object, but we also need to have an HTTP status code, very valuable to say, yep, it worked, or nope, it failed. 2 headers must be included in the return: the XAMZ request route and the XAMZ request token. These headers have to be part of the return every single time. Now, the values of these headers are also part of the request. They're in the get object context. It's the output route and the output token. Again, you just grab these from the request and you use them when you send the response back. Very easy to do. Other data in the request. The biggest other thing in the request that comes in is the user request URL. This was going out to a transforms bucket. It was looking for the sample text. There's our Lambda ARN. That's kind of the magic that calls the actual webhook for us. And if you look very closely here at the very end, I have this ampersand my header equals my data. This header and data was just additional request parameters that I put into my code. It gets handed along as part of this user request. This URL, by the way, is not required for the webhook to function. It's just a way for us to retrieve additional data. I don't need this to get the object. That happens with the pre-signed URL. So this is really just a simple way to have your developer be able to grab extra data sent to the webhook. This my header equals my data isn't going to be touched or processed by MinIO at all. It's just going to get handed straight through. In the next video, we'll show you how to request the transform object, and then we'll also get into some details on how to configure MinIO. I hope you've enjoyed this video. If you enjoyed it and would like to reach out with us, you can use any of the methods you see here on the screen. You can also Slack us on slack.min.io, or just hit a comment here on the video. Thanks, and we'll see you for the next one.